All right, so 4.3, that's not what I want. All right, so first off, they tell you, here's the theorem, that it's side angle side will always work, okay? Also, they tell you that side, side, side will always work. And we're going to get a couple more of these, but for now, you need to know that side angle side, 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 side works, and there's no angle side, side. If you ever use angle side, side, then you've made a mistake, okay? So go ahead and write down that there's no angle side, side. If you know that the triangles are congruent, then there's this other rule that says corresponding parts of congruent triangles are congruent, or we abbreviate that by CPCTC. We're going to use that a ton.
Yeah, we got that.
And,
yeah, I got that in the homework.
Which homework?
4.2.
Really?
Yeah, it was on the lot.
All right, so CPCTC means corresponding parts of congruent triangles are congruent. So that means that A is congruent to B, the angles, and they give you this whole long list of things. But if you have two triangles, then it has a part that's congruent on the other triangle. If one angle is 42 degrees, then there's a 42 degree on the other one, okay? So here, given that AB is parallel to CD, and AB, so they tell us that these are congruent. They also tell us in that it didn't get printed very well, but there's an arrow on here, okay? How can you tell that angle B, so this angle here is in question, is congruent to this angle here? So we're going to go ahead and write a proof. I'd like to answer your question, but we're just going to go quick. Statement, reason. Okay. I know that AB is congruent to DC, and that was given. So there's my side. Okay. I know that my angle DCA is congruent to angle BAC. Does anyone remember how I know that? No. How do I know that? Alternate interior angles of parallel lines. Okay. Are congruent. Yep. It's a rule we learned that alternate interior angles of parallel lines are congruent. So now I know that that angle, and then I can say that AC is congruent to AC. AC is congruent to itself. Reflexive. And watch what I just did here. So I told you that the side was congruent. I told you that the angle is congruent, and I told you that the side was congruent. I told you side, angle, side.
And then when it flips, it'll land on it.
Okay, so I'm going to now say that triangle ABC is congruent to triangle. I like to get the letters right. C, the same order. DA. What allows me to say that? Side angle side. Postulate. Okay. And now that I've said that the triangles are congruent, I can say their parts are congruent. So angle B is congruent to angle D. What allows me to say that? Corresponding parts are congruent, triangles are congruent.
Why did that computer programming thing?
Couldn't we just see this by looking at it?
We can say a lot of things by looking at them, but this is the step-by-step proof. Okay, we got to first say that the sides are congruent, the angle's congruent, the side's congruent. We got to say that that means the triangles are congruent. That means that the angles are congruent by corresponding parts of congruent triangles.
Because if you just disregarded the proof, because you just say ultimate angle, because parallel lines are two angles.
But these angles were not the same on the same transversal. Next, it says, show that there is a, you need that?
If you would have been following along, you would have it.
I didn't even read the question.
Okay, show that there is a rigid motion that maps triangle PQR to STU. So basically, what they're getting at is these are congruent triangles. They're just, you know, when people handed me an A, some people handed it into me like this, or this is actually B, and some people handed me like this, okay? And some people would say, well, those are two different triangles. Well, all I got to do is flip it over, and it's the same triangle, okay? So that's what they were getting at.
You rotate it 90.
Rotate it 90.
And then you translate it.
Okay, but see, if I rotate it 90, I agree. Like we could rotate it here, but if I rotate it, then this piece here would be up, and it doesn't match that.
But that's different letters.
So look, so essentially we have this.
Okay, then rotate 270. 270 to translate.
Yeah, just like everybody else said.
The triangles look like different shapes.
So I think what we want to do is rotate it, and I might have misunderstood you, 90 degrees this way. Okay, and then reflect. So all we got is, so really all the point of this is that we can do a rotation 90 degrees clockwise, and then a reflection. Well, we would want, once I rotate it, it would be like this.
Okay.
It would be,
If we would have did it 270 counterclockwise.
yeah. Not a big, I almost don't even care about this problem. I just want you to know that you can move it around and you can flip it over. So some people would say this isn't congruent because they're not faced the same way. Okay. Looking here, which of the following are congruent by side angle side or side side side? So you go through a lot in geometry where people get confused on which postulate to use and when you can use it. So which postulate would I use with these two triangles? Because we know 3 sets of congruent sides. How about this one? So we have a side, we have an angle, and we have a side. The key is that the angle has to be between the two sides. How about this one?
No, it's not. It's the thing. Angle side side.
Are we allowed to use angle side side?
We're not, because
Okay.
there's an angle.
So we, on this one, we say not enough info. Okay, we would need either another angle or another side. This one is side angle side. So do you see how the angle has to be in between? Just because you have an angle on two sides doesn't make it work. Yes. What additional information is needed in order to do side angle side or to use side side side? So in order to do side angle side, I would need to know what?
Angle and side and side.
Which one specifically?
The side AC.
I would need to know for this one that AC is congruent to
FD.
FD, thank you. And for side, 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 I would need to know. Yeah, I'm going fast.
AC is congruent to FD and FE is congruent to BC.
So I would need to know those other sides.
Not if you're paying attention, Maddie.
I am.
Yeah, brilliant.
Some of you are talking and not really focused. I didn't say your name. Well, here's a hint that you're not focused. You're not looking at the board and writing down what I'm writing down. You have that side written down.
Because actually I have it written down.
Okay, last one. Is triangle STU congruent to triangle XYZ?
Yes.
Explain. So how do we explain these things?
They both have the same test.
Statement, reason. We have to write a proof. Okay? So I'm going to say, I like to do them in order. You don't necessarily have to, but it makes sense to go ahead and give me a side, and then give me an angle, and then give me a side. So TU is congruent to ZY. How do we know that?
Because they have the one line.
Because it's given. Angle U is congruent to angle Z, given.
Why is there two givens?
SU is congruent to XZ, given. So they told us all this information.
And then it's the CPTC.
That tells me that their parts are congruent. What tells me that triangle STU is congruent to triangle XYZ is side, angle, side. It doesn't ask for anything about the parts. And I don't think we need to do the last one. Tomorrow is a work day. Today's work will show up in a few moments. If you want to retake the test, tomorrow is the retake.
Thanks.